Chapter 8, Right Triangles. Today we're going to cover Section 8.1, Similarity in Right Triangles. Your class opener is to simplify the following values. 8.1, Similarity in Right Triangles. Your objectives for today will be to determine the geometric mean between two numbers, state and apply the relationships that exist when the altitude is drawn to the hypotenuse of a right triangle. To start, list the numbers you should know the square root of. And I think of this as just list the numbers from 1 to 10. Square all of them and see what you get. And we know 1 squared is 1, 2 squared is 4, 9, 16, 25, 36, 49, 64, 81, and 100. So if I were to take the square root of any of the numbers in this column, I just get the number in the column to the left. So I know the square root of, say, 9, for example, is 3, or the square root of 49 is going to give me a 7. Okay. Simplify the following. 3 square roots of 50. What I really want to do is I want to split up the square root of 50 and get it to the smallest number I can underneath there. So what I'm going to do is this. I'm going to copy the 3 out in front and not worry about that for right now. But I'm going to try to take the 50. I want to split 50 into two numbers, one of which I know the square root of. So I'm trying to think of what are two numbers that multiply to 50. Well, 5 and 10, but I don't know the square root of 5 and I don't know the square root of 10. So another way to get 50 is 25 times 2. So I'm going to write that it's the square root of 25 times the square root of 2. Well, the nice thing is I actually know what the square root of 25 is. The square root of 25 is really just 5. So I'm going to rewrite the problem I have, copying the 3. I know the square root of 25 now is 5. And the square root of 2, I still don't know. Okay. Well, 3 times 5 out in front here is 15. And then I check. Could I split up two numbers that multiply to the square root of 2, one of which I know the square root of? And I can't. The square root of 2 is as simple as I can make it. So my final answer is 15 square roots of 2. Number 2, the square root of 7 times the square root of 14. Well, I don't know what the square root of 7 is. And if I try to think of two numbers that multiply to 7, that's not going to help either. I don't know what the square root of 14 is either. And if I try to split up 14, I only know that it's 2 times 7, and neither of those help either. So one way to solve this is actually multiply them together. So what is 7 times 14? And since those numbers were underneath the square root, the answer will also be underneath the square root. So I get 98. Now I look at the 98 and I try to split it up into numbers that I know the square root of. So if you don't have any idea, just start going through the list of numbers that you know. Well, is it divisible by 4, 9, 16, 25, 36, 49, the numbers we know the square roots of, and it happens to be that the square root of 98 would be the square root of 49 times the square root of 2, and I know the square root of 49 is really a 7, and the square root of 2 I can't simplify anymore. Number 3, first thing you have to be careful of is I can't reduce between the 3 and the 12 because the 3 is underneath the square root and the 12 is not, so I have to treat them separately. One problem though is you can't leave square roots in the denominator. So we fix it by doing something that's called rationalizing the denominator. So I would like to get rid of the square root of 3 in the denominator. So to do that, I'm going to multiply the denominator by the square root of 3, and I'm going to multiply the top by the same thing. Because if I multiply by anything over itself, I'm really just multiplying by 1, and multiplying by 1 doesn't change anything. So here's what happens. The top, 12 times the square root of 3, nothing changes. I can't multiply them together because one's in the square root and one's not. So I get 12 square roots of 3. In the bottom, I get the square root of 3 times the square root of 3, which is the square root of 9. And I actually know what the square root of 9 is. The square root of 9 is 3. So here's what I would do if you ever see this in the future. If you ever see that you're taking a square root times itself, you just end up with the number that's inside the square root. So if it was, for example, the square root of 4 times the square root of 4, the answer is just regular 4. Or the square root of a 5 times the square root of 5 is just going to be a regular 5. Okay. Now, I do notice, though, that the 3 now in the denominator that's not under a square root is going to reduce with the 12, which is not under a square root. And I'm left with 4 square root of 3 over 1, and I don't need to write the over 1. Number 4, looking to fix this. The first thing I notice is the 2 that's not under the square root can reduce with the 8 that's not underneath the square root. But I can't leave this square root of 2 in the denominator. So I'm going to multiply the denominator by the square root of 2, and I'm going to multiply the numerator by the square root of 2. In the numerator, the 4 and the 2, I can't multiply them together. One's outside the square root and one's inside the square root. Now, in the denominator, so similar to up above, if I take the square root of 2 times the square root of 2, I just end up with a 2. Or you can think square root of 2 times square root of 2 is square root of 4, and I know the square root of 4 is 2. And now I notice that the 2 outside of the square root can reduce with the 4 outside of the square root, and I end up with 2 square roots of 2. Number 5, square root of 45, let's see, I don't know what it is, but I could split up the square root of 45 into a 9 and a 5, so I'm going to do that. So this part right here is a square root of a 9 times a square root of a 5. This second square root of 5, I don't know what it is, so I'm just going to recopy it down, square root of 5. And now let's start to simplify. Well, I know what the square root of 9 is. The square root of 9 is just 3. And then if I look at the second part, I have the square root of 5 times the square root of 5. Well, I either just remember that that's a 5, or if you don't remember that, square root of 5 times square root of 5 is square root of 25, and the square root of 25 is 5. And now I have 3 times 5, which is 15. Number 6. The square root of 3/4. The easiest way to think of this is split it into 2 separate square roots. So it's the same as if there's a square root of 3 in the numerator and the square root of 4 in the denominator. And hopefully you notice right off the bat, hey, we know what the square root of 4 is. It's really just 2. So I get the square root of 3 over 2. I can't reduce them. The denominator is not a square root, so everything's fine. And here's my final answer. Number 7. Similar to the one before, I'm going to split this up and make it a square root of 5 over a square root of 6. I can't simplify the square root of 6, but I can't leave it in the denominator, so I'm going to multiply the denominator by the square root of a 6. I'm going to multiply the numerator by the square root of a 6. In the numerator, I get the square root of 5 times the square root of 6, which is the square root of 30. In the denominator, the square root of 6 times the square root of 6 is just going to give me a 6. I remember I can't reduce between the 6 and the 30. One number is under the square root, the other one's not. So I try to think, can I split up the square root of 30? Well, 5 and 6 don't know those square roots. 2 and 15 don't know those square roots. 3 and 10 don't know those square roots. So the square root of 30 is going to have to stay. Find the geometric mean between the following numbers. So I want to find the geometric mean between 4 and 9. So the easiest way for me to find the geometric mean is to make a proportion. The geometric mean I put diagonally across from each other, so the geometric mean is going to be x, and then the two numbers I'm trying to find the geometric mean between go diagonally the other way. And now I'm just going to cross multiply. So if I cross multiply, I get x times x, which is x squared, 4 times 9, which is 36. To solve an x squared, I do the opposite and take the square root. The square root of x squared is x. The square root of 36 is going to give me a value of 6. And I know that negative 6 times negative 6 also gives me a value of 36, but I'm looking for the number that's between 4 and 9, so I'm only looking for the positive value. So the geometric mean between 4 and 9 is 6. setting up the geometric mean between 6 and 10. So my geometric mean goes diagonal one way, the 6 and the 10 go diagonal the other way, and I cross multiply. So x times x gives me x squared. 6 times 10 is 60. To get rid of squaring something, I do the opposite and take the square root. And now I think x is going to equal, well, what can I do with the square root of 60? Well, it doesn't come out nice by itself, so could I split it up into two numbers that I know the square root of one of them? So I just start going through what numbers go into 60 that I know the square root of. Well, 4 goes into 60, and I know the square root of 4. And 4 goes into there 15 times. So I really know that the square root of 4 is 2. The square root of 15 doesn't come out nice, and I can't split it up at all either. So here the geometric mean happens to be 2 square roots of 15. And your closure. Explain how to simplify the square root of 80.